how are you like nah, they're trying to upgrade the FFAR in that game. That's why you play League was pain. You get every impression. You put a scope on a gun and go through the night and stuff. Like if you like yeah, like
Hey guys, big day.
is it 3 topics, right? Wait, it's 8 topics? Wait, what's just an outline, right? What?
Okay, anyways, whatever you guys are saying, what we're doing today is right triangle trigonometry. Sounds crazy. You're going to be like, oh, this is chill. Trust me. Also, the law of sines. Sounds intimidating. It's not. We got this. Big day though. First, we're just going to be practicing going through your special right triangle shortcuts. Okay? That's what you'll be doing here. We're going to look at a little more of that over the next few problems. And then we'll slide into sine, cosine, and tangent. Again, don't be intimidated by weird math names. All of math sounds weird and complicated. You guys are realizing you got this. It's your pep talk. Now let's go out there and learn some math. Yeah! Let's say one more minute here. I'm not saying this facetiously. I love that you guys are actually communicating about what you got. You can hear a pin drop in some of my other classes, so it's kind of annoying to hear. So yeah, I'm glad you guys are checking in. Hey, what you got? I got this. Oh yeah, me too. Or oh, how'd you get that? That's good. It's like what used to happen before all this craziness.
Yeah.
Right. So, speed up the process. Yeah. Stop being confused. Yeah.
Okay. You've got formulas that relate the sides to each other in a 45, 45, 90. It's a little bit more basic because like I think I heard Hank saying, the legs are always going to be equal, the same. What are the legs? Good question. What are the legs of a triangle? Okay, the two little things are always the shorter sides. They're the sides of the triangle that meet at a right angle. There's a fancy word that starts with P. They're the perpendicular sides, yeah. The long one is the hypotenuse, right? You guys know this. So I can say, let's say I want to get x first. To solve for x, I'm going to say that hypotenuse equals leg times root 2. Plug in what you know. What is the hypotenuse?
6.4.
I'm solving for leg. For x, what is the leg? X. And to undo multiplying by root 2, you simply need to divide by root 2. Good. Now, I know we spent a lot of time dealing with radicals and how to clean stuff up. Remember, this one says round to the nearest tenth. So we can just go ahead and put 6.4 over root 2 into our calculator. Help me out, it should be something less than 6.4. 4.5. People good with that rounding?
Yeah.
Okay, nice. Well, cool. I don't have to do anything to get y because the legs are always the same.
I was on the next.
You were already a step ahead. The legs are always the same in a 45, 45, 9, right? Sweet. So here, we don't even need to pick up a calculator. That's the nice thing about these shortcuts. We've been given the hypotenuse. I'd like in a normal world for us to be able to just say, cool, short leg is 9, long leg is 9 root 3. If making that jump that quick is tough, which it could be because we just learned this stuff the other day, then we can say, look, hypotenuse equals short leg times 2. Let's plug in what we have. Do we have the hypotenuse? 18. Do we have the short leg?
Not yet.
Or Y.
It's y in this one, right? So y times 2, I undo times 2 by dividing by 2, and y equals 9. Like I mentioned on Monday, once you got the short leg, then you're psyched, because getting all the other sides, in this case just the long leg, is easy. You just multiply the short leg by
Yep, I got
square root of 3. Excellent. Cool.
Is it, it's root, why is it root 3 again? I forget. Instead of root 2.
60.
So when we kind of came up with the rules, we took an equilateral, chopped it in half, right? That's where the half idea came from with the leg and the hypotenuse. Then when we did the Pythagorean theorem, it's always going to be this side times root 3. Good question.
Is the short leg always next to 60-degree angle?
Yeah, so let's phrase that differently, but you're right. The short leg is always across from the 30-degree angle, the smallest angle. Right? The shortest side is always across from the smallest angle. Good questions. All right, let's finish up the last section. Here's kind of a huge summary. Remember, one thing we talked about earlier in that section was a squared plus b squared equals c squared is what? The Pythagorean theorem, which applies to what?
A right triangle.
It applies to a right triangle. But flip that around, and if you don't know it's a right triangle, but the sides do have that relationship where the two shorter sides squared added together equals the long one squared, well, guess what kind of triangle it has to be? It has to be a right triangle. So, with that information, you've got sides of 40, 41, and 11. How can we test whether or not this thing is a right triangle? All right, so really what we're going to say is 11 squared plus 40 squared, is that equal to 41 squared? Let's do this in two separate steps. Type into your calculators 11 squared plus 40 squared. Is it 1721?
Yeah. Oh yeah, I got that too. Yeah.
What? Come on, what's 11 squared? 121.
Yeah.
40 squared? 1600.
Oh, wait.
Oh.
All right. 41 squared, I don't have that one, so help. 1681. Hey, are those things the same? No. These are not equal, so not a right triangle. Something I would teach you when I have you twice a week, or for 2 quarters, I should say, is fine. It's not a right triangle. So what kind of triangle is this? I'll give you a multiple choice.
Yeah.
Is it an acute triangle, a right triangle, which we just figured out it's not.
No, B, C.
Stop, hold on. Or an obtuse triangle.
A.
No, cute, but it's smaller than that number. It's
Hey.
obtuse. No, or obtuse, one or the other.
Well,
Okay.
yeah, C, we already proved it's not.
Obtuse.
So
Because it's the longer side.
here are the sides if it was a right triangle, and here's C, right?
Yeah.
But my 2 legs squared turned out to be longer than C squared, right?
Yeah.
So let me just first.
So it's a skew.
So it's an acute triangle.
Alright.
I said A. We're insane. Hank, we got it wrong.
I will not
See, sometimes.
ever be assessing you guys on that. I just wanted to have you think about it for a second. All right. 3 more sides, 20, 21, and 29. Tell me what kind of triangle it is. Very soon it will be. This is sort of the end of 8-1, but yeah.
It's a right triangle.
It is?
Yep.
So this actually is true.
How'd you get that? I don't know.
I got 849.
What?
I got 841. Yeah, I got it wrong.
29 squared. Yeah, I got it right.
8. Sorry, what'd you get over here?
841.
And 29 squared?
841.
That makes sense. Because of math. Yeah. That's why I was like, how'd you get this math? Get it right.
All right.
How do you know which numbers to wear?
Here's the thing that doesn't matter. Does it matter if 20 or 21 are A and B? No. I could do this in either order. What matters is that the longest one has to be C. Okay. All right. Well, here we've got a pennant, like a thing that you hang up that represents a school or a team or something. And Charles wants to hang it shown vertically in between 2 windows that happen to be 19 inches apart.
That's specific.
Will it fit?
That's so good.
Yeah, 19 inches, that's like very close.
Will it fit?
What?
So first we do,
No.
so you do math.
That's the pennant.
Oh, right. Yeah.
Yes, no, it won't.
No, it's
Yeah.
gonna be big.
It won't.
No,
It
no.
won't.
It won't, it's 1.5 inches,
Yeah.
so.
People who are saying no, talk me through your logic.
Because
Anna?
41 divided by 2
Is,
is bigger than 9.
what is 41 over 2?
20.5.
Good call.
Yeah.
Because that's bigger than 19, is it
So
gonna
what if
fit?
they want to kind of shape the window? Like by it.
No, this is-
I don't know if that's the
Which
way.
way are they trying to hang the pennant? Well, no, hey, it says 41 inches, obviously it's not gonna fit. Well, then why would you? Yeah, but like, why would you start?
Let's not overanalyze these problems that much. Good call. We good?
Why the window so close?
Again,
That's like 19 inches.
That's not nice. That's
So-
like 3 feet.
you were able to, here, go back. You were able to analyze that because you knew it was a right triangle. You knew the hypotenuse. What else did you know? The 30, right? Because of those shortcuts we learned the other day, you could say, oh, well, that short leg's just half the hypotenuse. What if it's not a 30, 60, 90 or a 45, 45, 90? Well, that's where trigonometry comes into play, okay? So, thinking about similar triangles, we've got two similar triangles here. We got more than enough information we need to show that they're similar. Why are those two triangles similar?
Because they're proportional.
They are, because all the angles are equal, which makes them similar and proportional, right? So here's what Diego's saying. He says we could set up a proportion by doing JK over MN, this side over this side, equals JL, there we go, JL over MO. Is his proportion okay?
Yes.
I agree, he's being consistent. This side over this side equals this side over this side, right? How about Rebecca? She's saying JK over JL equals MN over MO. Is that also okay?
Yeah.
Right, and as you guys learned in setting up proportions, there's usually more than one correct way to set up a proportion, right? So both of these are okay, which means, well, we'll get into that in a second, all right? And I like the fact that finally our book is cutting to the chase a little bit. I'm just going to throw it all at you now. Have you ever heard of the acronym SOHCAHTOA?
Yeah, every day.
Every,
No.
well, then you're in luck. Now you'll know what it means, but maybe you haven't heard it. So, ka.
No, that's not how I want to spell it. Yeah.
So-
S-O-K.
Well, that's how you're spelling it now, and it's going to be helpful. There are three new functions you're learning, or ratios: sine, cosine, and tangent. Okay?
I don't know.
You'll learn why in a second. So let's call this angle theta. Usually when I talk about theta, students start freaking out because they're like, theta, what is that? Well, we run out of letters in English, so then we start borrowing variables from the Greek alphabet. Why? I don't know, just deal with it. Theta is a Greek letter, but it's a very, very commonly used letter to describe an angle in a right triangle in math, okay? So this is theta. Go ahead and say it out loud so you're getting used to it.
Theta.
Theta, yeah, T-H-E-T-A.
Is it just like a circle with like a half line?
It's a circle with a little
Smiley.
thing written through it.
That's not smiley.
It's got a little
It's
curve.
a band.
Oh, okay.
It's the drip.
Like a what?
It's the drip.
Yeah, sort of, but it goes through the middle. Cursive O, I would say, is.
Yeah.
Yeah, there's one on the calculator.
It looks like Saturn.
No?
Oh, yeah, I see it. Where?
Second row, second column, maybe?
Yeah. Is it like this stop sign?
Oh, wait, never mind, bro. I don't know anything.
Oh.
Bro, I see it.
All right.
I've seen it on Google.
So, theta, we're cool with it. It just means an angle in a right triangle, all right? So here's the thing. If you're hanging out at theta, there's a specific name we're going to give each side based on the location of theta, right? If this is theta, This is the side across from it. So I'm going to call it the opposite side. This is the side next to theta. There's a fancy word in English that means next to, called adjacent. You may have heard of the word adjacent. Your house is adjacent to your neighbor's house. It's just things that are next to each other.
I thought adjacent was like diagonal, or like a cross.
No.
I don't know, like
I thought it meant adjective, but I was wrong.
Now we know what it means. It means next to. And here's the good news. You already know what the long side of a right triangle is called. It's called the hypotenuse, right? So if I'm at theta, here's why we call sine. Here's what SOHCAHTOA is referring to. Sine equals opposite over hypotenuse. So sine of theta equals the opposite over hypotenuse. Ca stands for cosine equals adjacent over hypotenuse. So I'm going to say that cosine of theta equals the adjacent over hypotenuse. Take a crazy wild guess what TOA stands for. Tangent equals over adjacent. Yeah. Tan of theta equals opposite over
Sarah, how did you know that word?
adjacent.
It's on there.
Where?
Do you have to know this?
Yep,
Bro.
that's why I'm teaching it.
Yeah, he's just saying it. No, he's just it's gonna be for his own pleasure.
Yeah.
Okay.
Yeah.
Yeah, so start.
How do I spell
Theta,
theta?
THETA. But I just put the little circle with the arc through the middle.
T. Theta.
Looks like an egg. Thank you.
I spelled it so wrong. Oh.
It doesn't give
Is that gonna be like when we start seeing triangles, are we gonna see that little thing? Like, is that
I did
gonna
not spell it. I know so.
It just means that.
Just means an angle in a right triangle. It's like X or Y or theta.
So, like, I just got to- Yeah. Like they say, it will air.
Sure.
How do they run out of letters in triangles? Aren't there only 3 sides of triangles? There's literally 26 different pieces.
Well, we didn't invent it, and the Greeks did, so that's probably why we use theta. So, you can say what if all you want, but we're using it, so get used to it.
Yeah.
So, here we go. Check it out. We're going to look at the sine of angle B. Hey, if you're at angle B, what's the opposite side? AC. And what's the hypotenuse? Okay, because the reason I brought those two up is because sine equals opposite over hypotenuse. So the sine of B is just AC over AB. How about the sine of angle E? DF is the opposite side over DE. Right. Now, since those angles are the same, and since the triangles are similar, then these are always going to be the same. Look, the most important thing is once we start actually solving for missing angles and missing sides, that's the thing that you're taking in. This is some background to show you that sine of the same angle measurement always gives us the same thing. Okay. So, again, like a lot of stuff, once we stay awake and start putting it into practice, it'll be a little bit easier. So, we're going to be just at angle H. One thing that helps a lot with trigonometry, at least at first, you guys will start getting the hang of this and not do this next step. But if you're at angle H, let's label all the sides. The side 9 is next to it. So what am I going to call this side next to it? The adjacent side. Good. The side 12 is across from it. So I'm going to call it the opposite side. And no matter which angle I'm talking about, 15 is always going to be called the hypotenuse. Very good. Now that we've got our triangle labeled, I can say that the sine of H, now sine is always opposite over hypotenuse. If you're at H, what's the opposite? And what's the hypotenuse? 15. How about the cosine of angle H? Well, cosine equals adjacent over hypotenuse. So 9 over 15.
Then 12.
Good. The tangent of angle H, which is the opposite over adjacent, 12 over 9. Uh-huh. All right. Hey, I'm just going to rewrite those. Because now we're going to do those same functions. Okay, I'm going to switch these around, sorry. But we're going to do it not for angle H, but for angle F. So once you guys start writing those down. So sine, cosine, and tangent, but not where H is, where F is. So keep in mind, it's going to change something. It's going to change what the opposite and adjacent sides are, right? If you're at F, 12 is now the adjacent side. 9 is the opposite side. But 15 hasn't changed. 15 is still the hypotenuse, right? So, opposite over hypotenuse for F for sine, 9 over 15. Cosine of F is going to be 12 over 15. Tangent is going to be 9 over 12. So some relationships to look at here. I don't want to harp on this too much because I just want to get you guys practicing this here. But how do H and F relate to each other? Let me give you a different question. Say H is 50 degrees. What does F have to be? It's got to be 40 degrees, right? In other words, since this is a right triangle, H and F are going to always add up to 90, right? So H and F are complementary angles. They add up to 90. And look what happened. Sine of H is 12 over 15. Was anything else also 12 over 15? Cosine of F, right? In other words, cosine of the angle that adds up to 90 with H. Here's one thing we can do on our calculators that'll be kind of fun. Type in sine of 40. And hold on, time out. One important thing I need to show you. Let me bring my calculator on the board.
40 and then sine.
I'll show you. Before you start typing in anything, we need to make sure we're in the correct mode. We refer to, in this class, angles in what units? Degrees, right? There's other ways you can conceptualize angles in math. We're not going to go down that road. So you just need to make sure that when you hit the mode button on your calculator, it's just the top row, second column, that you look down and you make sure it's in degree mode, not radian mode. Mode is in the first row, second column. You go down and highlight over degrees and then hit enter. Now, if you're not using a TI and you just want me to make sure, I'll check your calculator.
Let me see Hank how to do it. I don't know. Yeah.
So that says you're radian.
Did you get it?
Now you're radian.
Oh.
We're gonna do my.
Show
Show me Hank how to do it. Hi, you see it? So, you put in 40, then you click sine. 0.74. That's good. Is that the right one?
I don't know, Hank. I'm no good to be honest.
I don't know.
Oh, you always
You
use
grab
one
it.
and then people, how do you take it?
Yeah, grab, and I would say grab one of the graphing ones, but it's up to
That makes sense. Which one's one of the graphic ones?
Bro, Hank,
you. Yellow, back on my desk.
Alright.
So, questions on calculators, are we good?
This thing's like a machine. Oh.
oh, Hank pulling up.
The one that says sign.
I want to get flashy for someone.
Oh.
You have to have a SIM card. I know.
See how it says?
That's what it's for.
That's what you want.
Where do you put a SIM card?
I don't, that's what I'm saying.
Yeah, it's not.
All right, so
Here it is.
here's what we do. You press sine first, type in 40, and then it's not going to affect your answer, but it's a good habit to get into to close your parentheses. We get 0.643.
Yeah. You get what first?
On these calculators,
Error.
you have to hit the degree first and then hit sine.
Sine and what, 40?
Wait.
Sign in 40 and then close your parentheses.
Thank you.
One at a time.
Click enter.
Then you know what you're doing.
It always is.
Hit 40.
Whatever you
Is
say.
that 0.64?
Yeah, 0.64278.
Why is it negative?
How are you getting negative?
If, even though that's your personal calculator, if you want to borrow one of these others. It's a little more user friendly.
Charge this thing? Are you
I know.
Second? Why do you?
I just got my calculator because I can't imagine.
Okay. Here's what I was getting at. Now hit cosine of 50.
Oh, cos?
Oh, wow.
And sine same time?
I got the same answer.
Wait, cos and sine same time?
No, cosine, cos stands for cosine.
Okay.
So hit
Oh, that's
punch.
what all these are for. They're like this. Oh, God.
Yeah,
I know we're just doing
It's like you're finally seeing the world around you at a different level.
Go sign up for it.
I know I
Yeah,
have a
yes.
calculator.
No, 50.
Yeah, I got. I got the same answer.
So forever.
Put it in.
Is that what it is? I got the same answer.
Yeah, so I do. Hey, we're right.
Yay! We can use a calculator.
We're too smart, bro.
I know.
You can literally type things inside of the calculator.
Okay. We're gonna do lots more with the calculator, like for the rest of your life. So let's keep going.
Tangent?
All right, I'm over this. Let's keep moving here. I don't even want to deal with special right triangles right now. Because, hey, hit tan 45.
Ooh, yay.
I got one.
Remember close?
Good. Why'd you get one?
Because
Oh,
it's
wow.
45.
That's thing.
What do you know about the opposite and the adjacent in
They're
a
the
45,
same.
45, 90? They're
The
the
same.
same, right? Any number divided by itself equals 1. All right. We're moving on. Now, let's get into this. Here's where trig gets useful. Now you've got a right triangle. You know one of the angles. You know one of the sides. In a situation where you normally wouldn't be able to do anything, well, now you can. I don't know if that's good news or bad
Well,
news.
you actually have two.
So, check it out. Based on where 43 degrees is, let's label our sides. X is the opposite side, good. 12 is the
Adjacent.
adjacent. You all should be writing this down as I'm writing it. Now, do I even need to label the hypotenuse? No, because this doesn't pertain to this problem, right? We don't know what it is, and we don't want it. So, hey, I've got the opposite and the adjacent. Now I have to figure out which of the three functions we're going to use. Am I going to use sine, cosine, or tangent?
No.
Or.
No.
Which one uses opposite and adjacent? Tangent does, right? Tangent of theta equals opposite over adjacent. So if you want, you can always start there. And then plug in what we know into this problem. As I've said all year, we usually use geometry to start the problem and what to finish it.
Algebra.
Algebra, right? Same thing here. Tangent of, what's theta? 43 degrees. What's the opposite side? X. And what's the adjacent side? 12. And now geometry is pretty much over in this problem. Now it's algebra. Hey, X is being divided by 12. Cool. In one step, I can get X by itself by just multiplying both sides by 12.
Wait, did we just put in our calculator tangent 43?
Here's what you can do that's even better. You can put into your calculator 12 tangent of 43. So check me out. I'm going to do that on the calculator here. 12 tan 43. Again, you don't have to close your parentheses, but it's a good habit to get into when we're going to do more complicated things soon.
11. Yeah, I got 11.
And I get 11.2, let's call it. Here's the nice thing. I can look at my triangle and pretty much know for sure that I did it right, because our angle is a little bit less than 45 degrees, right? If it was 45, I wouldn't need to pick up a calculator. I just know it was 12. the angle is a little smaller than 45, so x should be a little smaller than 12. And guess what? It was. Okay? Let's do another. All right. Ooh. Different angle. X is in a different spot. So same deal though. Let's label our sides. 13 is going to be the opposite side. X is the adjacent side. Meaning we're still going to use which of our three trig functions? Tangent again, right? Opposite over adjacent. So if you like at first, start with just the basic rule for tangent. Tangent of theta equals opposite over adjacent. Then plug in what you've got. What's theta in this one? 47. What's the opposite? 13. Okay, and what's the adjacent? X. Yeah. Now, I'm going to show you something that will allow you to get x by itself in one step. I'll go back to that in a second here, but I say I've got 15 equals 3 over x. How do we solve this for x?
You know,
And then you multiply by
times 3, right?
Then I'll have 45 equals 9 over x.
Times X divided.
Okay, good call. Let's first multiply by x. Now x is out of the denominator. That helps us out a little. I got one move to do. How do I get x by itself if it's 15x?
Third.
Now here's the deal. Here's what you started with. And here's what you finished with. Where did 3 go in this process?
No.
It didn't go anywhere. The only thing that happened was that 15 and x switch spots, right? That always happens in a proportion. So go back to our little scenario here. It's the same deal as that. X is stuck on the bottom. So I'm just going to switch x with tan 47. I'm showing you this way because then you can just put it in one step in the calculator. That means x equals 13 over tan of 47. And again, over means what operation? Divide, right? Division. So try typing into your calculators 13 divided by tan 47.
I got
12.1.
12.12.
Now, if you use one of these calculators here, sometimes they like reset and default to a different mode. So if you get like a really bizarre looking answer, like we should expect something around 12, but if you get negative 0.3, chances are your calculator is just in the wrong mode. And feel free at any time, if you've got calculator questions, whether it's a test or not, always ask me. That's totally fine. Okay. All right. Back to this. So we're saying that x is 12.12 to be precise, or something, 12.1-ish.
Yeah.
All right. Now again, we can expect that because my angle's a little bigger than 45, so my opposite side should be a little bigger than my adjacent side. How we doing so well?
Okay.
All right. This is the tip of the iceberg, though.
Oh.
It's all right. You got this.
Probably not.
No, you got this. You got this. All right. Oh, a little different. Same deal, though. Let's label our sides. X is the, oh, there we go. X is the opposite. 9 is the hypotenuse. got one of our angles in there. So, different function this time. If we're talking about the opposite and the hypotenuse, which of our three functions should we use? Sine, yeah. So I'm going to say that sine of theta equals opposite over hypotenuse. And let's just plug in what we've got. Sine of 57 degrees. Our opposite side is x. Hypotenuse is 9. And again, the comfort you should take in this is now it's an algebra problem. X is being divided, so we should just multiply both sides by 9. And we can put 9 sine of 57.
I got 7.548. Okay.
7.5 what?
7.54.
5.4? Okay, let's call it 7.5.
Yeah, because the other one, it could. It's just 7.5.
Okay.
It's 7.5.
A lot of times I might have you round a little bit more, but for now, let's just try to get the concept down and not worry about our rounding.
7.5.
It's not a religious act. It's simply sign, not sin. I'm just kidding. 9, you can either do 9 times, or you can just type 9 sine 57.
No, but what if you're in a crossroad?
We should just do
Just move Put that 9 next to it at the top. Was that, you put that there after?
I put it after I multiply both sides by 9. Yeah. Now I got you.
Thank you.
How we doing? We good?
Yeah.
It's not so bad, right?
Yeah.
Once you get it set up, it's like one step. Got another one here. I think you guys are so talented that you might be able to rock this all on your own.
Yep. I got it.
I'll give a minute or so. Hey, I tell you guys straight up if you couldn't handle it, so.
I got it. So then I got. I'll just wait actually. 17. Look good. You get that 13.
I got 13 too.
It's like it.
Yeah. Do you think? Why do you think I didn't?
Spoiler alert.
Yeah. Fast. Now
I just need to know what they're aiming
It's
for.
13.
You know?
Thank you, Hank.
All right, hey,
Wait, I'm not done. I'm sorry, I'm slow.
don't be, no sorries.
Okay.
All right, hey, as you guys are working on this, I'm gonna label my triangle. X is the adjacent side. 17 is the hypotenuse. So I'm gonna say, ooh, adjacent and hypotenuse. Looks like we're using cosine, huh?
Cosine. I was gonna say cosine.
That's fine. I mean, pretend to just say cosine. But it's confusing because the other one's sine. Don't worry, when we start doing in pre-calc, cotangent, cosecant, that's gonna be fun. Yeah,
I don't know.
Oh.
don't worry. A couple years from now.
Okay. Outside.
So hey, cosine of theta equals adjacent over hypotenuse. Let's plug in what we've got. Theta is 40 degrees. The adjacent is x. Hypotenuse is 17. And we're like, word, x is being divided, so we will multiply. Just type 17 cosine of 40 into your calculator. It better be less than 17 because we can't have a leg be longer than the hypotenuse, right? And I'm just going to use mine here. 17 cosine of 40. 13.02, I'm gonna call it 13.0. So far, so good.
In our answer, should we put like degrees?
No, it's not a degrees.
Oh, yeah.
X is the length of a side.
Oh, right.
So we'll get into very soon how to actually use trig to find the angles. It's not bad.
Yeah, everyone needs to chill. We got this.
Yeah, there you go.
I said it, but goofiness.
One
Got
more.
it already. 19.0. Jeez.
Have you already finished that? I haven't even read all the numbers yet.
I was like, what?
That's, now it's gonna be a lot less.
Okay, that was understood. Just guesses. I got that. Big clutch. I got it. You don't need to tell us.
But hey, as you guys are finishing up, I'm gonna label my sides. X is across from 31 degrees, so it's the opposite side. 22's our hypotenuse, and then we have to pick the right function. Opposite and hypotenuse tells me I should use
Oh, wait, no.
sine.
See,
Sine is opposite over hypotenuse, right? So sine of 31 equals x over 22. Multiply both sides by 22. I can put 22 sine 31 in the calculator. Not 2 sine 31.
should we guess? One set.
11.3. What?
Should we guess the length?
Oh, I said, what's the difference between a row word ball and a word ball?
Neither. I don't really use either of them. Don't worry about it. This, the funny thing is I actually had for about a whole school year before I realized I had wall and word backwards. It said wall word up there. So that was entertaining. So,
Yeah. Wallward. Yeah. That
Hey.
makes sense.
good news. Do you need your calculator for this one?
Yeah.
I know.
No.
Why not?
Not
Do you have an answer?
No. Wait.
And
It's a 60, 30, 90.
it's a 30, 60, 90, yes. So, hey, let's get the
15,
short leg first. Because I know long leg equals short leg times root 3. How do you get x by itself? 9 divided by root 3, which is 9 root 3 over 3. What do you mean what?
How'd that just happen? What?
What did we do from here to there?
Don't you, how we
We like.
rationalize?
You rationalize the denominator. Cammy's remembering it, you guys.
Wait, but if you divide by, or like divide the s out of it, then wouldn't you have root 3 over 9?
How do I get x by itself if it's being multiplied by root 3?
Divide by 3.
Divide by root 3.
Oh, I thought divide by x. Never mind.
It's okay. Hey, and then we rationalize the denominator. And then what can I do here?
Right.
It's just 3 root 3, which makes y
What? You-
Oh, no.
I was.
6
I usually do.
I thought it was 9.
root 3. Okay. Guess we still need a little more practice with the special right triangle. That's a tough one when you're just given the long leg and it doesn't have the root 3 attached. Anyways, Here, use the diagram. It's very helpful. It's all for X.
So,
So let's label our sides. What's 12 and a half?
Long leg.
Next is the opposite.
Oh, and let me guess.
Which trig function uses opposite and adjacent?
I got 2.
I think I did it wrong.
Yeah, I did. I got
I'm guessing
2.7.
Yeah.
I got 2.7.
I did it.
Now, okay, so how do I get X by itself?
You multiply.
By 12.5?
I clicked the wrong.
2.6, that sounds right.
2.656.
Yeah, and according to
I
math,
clicked the
I got 2.5.
instead of the other.
Yeah.
How'd you get 2.5? That doesn't make any sense.
I got 2.66.
I got,
Yeah.
Yeah.
Yeah, 6.6. Yeah, you're right. That's fine. Well, then you have a big problem.
Hey, so what are our units? Miles. So that to me seems like a pretty sharp angle,
Yeah.
because to be a horizontal distance of 12 miles from the airport and already be 2 miles above the airport, I don't know.
It does make
Anyway.
me feel like it's 2 miles above the airport.
Yeah, it looks like about like 2 or so.
That's like 10,000.
Okay.
that's a tall airport.
What about the airport?
Now, it says it's time for
Inverse trig.
inverse trig. Just means instead of solving for the sides, we're going to use trig to solve for the angles. Okay, so find the measure of angle A and angle B. You guys pick. Which one do you want to get first? We'll take a vote. All in favor of A?
Hey.
All in favor of B?
No.
Wow. It's unanimous, with several people abstaining, that the A's have it. If you're at angle A, then we should label our sides correctly. One is going to be the adjacent, it's next to angle A.
That's the exact same thing. Oh.
So far, it's,
Not right. Not
Yep.
that way.
4 is the
Hypotenuse.
hypotenuse,
That's how.
and A is going to be the theta, or the angle that we're solving for. So now we have to pick the right function. If we're dealing with adjacent and hypotenuse, we want to use cosine, right? So I'm going to start with cosine of theta equals adjacent over hypotenuse. Let's plug in what we want and what we know. We're trying to solve for angle A. The adjacent side is 1, and the hypotenuse is 4. Look, all of these ratios, sine, cosine, and tangent, they're all functions. To be a function in math, you'll learn this more in Algebra 2, you have to have an inverse. Well, the inverse of sine is simply this weird thing that's called sine inverse, and you may have seen it already on your calculator, right above sine.
-1.
Yeah, it looks like to the -1, right? That technically means sine inverse, or cosine inverse, or tan inverse. So here's what we do. Hey, if you guys had something that said 5x equals 15, how would you solve this simple little equation? Divide both sides by 5. Because division is the inverse of multiplication, right? Exactly. So we use inverse operations to solve for variables in math. We actually do the same exact thing here. You don't need to show this step. But technically, you're doing the inverse cosine of both sides. We can just go straight to saying, look, I've got cosine of A equals 1 over 4. So angle A equals the inverse cosine of 1 over 4. You're getting in the 70s. Looking at this triangle, which is more or less drawn to scale, that means, okay, you're getting an error.
I don't even know what's happening in this calculation. That's fine.
So a good back button on those calculators, if you just hit second mode, it might escape whatever thing you've pressed. But hey, I'll be right over there in 1 sec. So here's how we're going to do that. Check out my calculator here. I don't want cosine, I want the thing above it, right? So I have to hit shift or second, depending on which calculator you have, and then cosine, so that I get this cosine inverse symbol. We can just put in 1 over 4. Again, it's a good habit to start closing your parentheses. And I get about 75.5 degrees.
Yeah.
This is like.
Hey,
Yeah.
let me see what's going on.
I don't even know. I really do. You get to download after you I forget why. But even everything. And
Are you guys able to get 75.5?
yes.
Yeah.
If not, let me know. It could be a calculator thing or just how you're typing in the buttons. And so in this calculator, if you guys aren't necessarily using the same one, you probably had to do 1 over 4 first, right? For 0.25, and then second cosine.
Yeah.
Just depends on the calculator. But ask me if you guys are having troubles. Otherwise, we're going to keep going. Oh, wait, hold on. Now we need to get angle B. Do we need to use trig though? That's 75.5 and it's a right triangle. This is just 14.5, right?
Yeah.
Now, I'm no fortune teller, but I bet if you hit sine inverse of 1 over 4, you'd also get 14.5 degrees. So, because, like I said, we could have solved for angle B first, just using inverse sine instead. Does it give you 14.5 more or less?
Yeah.
Yeah, if you guys do one on your own here.
Big.
So, there you go. Solve for angle P or Q first, and then use triangle sum to get the other one. Because it was 1 over. Well, not cosine sine, because that's like telling the calculator that the adjacent side is not. But it was cosine inverse of 1 over 4, so if you do 1 over 4, on that.
33.7. No.
Wait, what'd you get? Oh, that's all that I got. What did you get? I got 48 points.
I did
For
not get.
Q or P?
Or
Yeah.
C?
You?
I think it's Q.
Did you get study down there?
That sounds like that. Yeah, same.
Okay, so
Q.
I'm gonna solve for angle P. If I'm at
I did.
that location in the triangle, if I'm at P, 3 is the adjacent side, 2 is the opposite. And opposite and adjacent tells me to use sine, cosine, or tangent. Tangent, yeah. So I'm gonna say that tangent of angle P equals 2/3, meaning that P is simply the inverse tangent of 2/3. Go back to what we were saying earlier. I should expect something under 45 degrees because my opposite side's less than my adjacent. So I hit second tangent, 2/3, and I got 33.7.
You got it. That's good.
To get the other one, I don't need to use trig. I know that 33.7 and Q have to add up to 90. So that means Q is just 90 minus 33.7, which is 56.3. How would you? Yeah.
Well, you find that's just like subtracting, like 90 and the English algebra. You want us to use the tangents again? Or
It's up to you. If I was doing this at home and I had enough time, and I'm kind of a dork because I like making sure I'm right, I might do both. But you could do either one and they would both be acceptable on a test. Once you've used trig or inverse trig to get the first angle, and if you just then use triangle sum to get the next one, that's totally fine.
Oh, yeah, because they, why didn't I think of that? I was like, oh yeah, they add us to 90. Yep. Yeah.
Cool. So we're halfway done. Not really more, because now you guys are like, huh, yo, I got trig. Right? Come on, it's not so bad. One more.
Got it.
Don't base it on how it looks. Meaning if you're like, oh, well, that's the same, so it's 11, because it looks the same. That doesn't work out.
What if there's no hypotenuse?
There is, it's 18.
Oh, yeah.
So the reason why this one's a little tougher, it's oriented a little bit awkwardly, right? So it's up to you whether you want to solve for angle R or S first, doesn't matter. But based on which one you choose, it's going to then affect what the other side needs to be called, right? So if I'm going to solve for angle R first, what side is 11? It's the opposite. And 18 is the hypotenuse, right? Because it's across from 90. And that's maybe one of the more common mistakes is you can easily confuse adjacent and hypotenuse.
That's because they look adjacent.
Yeah.
Because it's next to one of the angles, right? But remember, the hypotenuse is always across from the right angle. So opposite and hypotenuse. Sine of R equals 11/18. So R is the inverse sine
Yeah.
of 11 over 18.
Boom, boom. 36. Um,
37.7.
yes.
Yeah. 6, 6.
And then S is just the complement of that, which is 51.3. My bad, 52.3. 51.2.
Is anyone on Zoom?
Yeah.
No.
Yeah, Hank, here. Zoom right
Yeah,
there.
it's on there.
Okay, that was trig.
And then,
Wipe your hands and be like, yeah,
Yeah. Yeah.
nice. Because now it's time for law of sines. Now, do you guys need to like stretch and stand up and move around a little?
Yes.
Okay, here's what we're gonna do.
so 5 minus 4 is
5
1.
jumping jacks.
Oh, never mind.
I thought this was like a, I thought this was like a pattern. I thought this was a problem.
Hey, regardless, you guys don't need to do a workout now. Just stand up, move around, still keep 6 feet. Stretch it out.
Because he was playing.
I mean, if you want to do 5 jumping jacks, 4 push-ups, 3 sit-ups, 2 squats, and 1 something else, go for it. But,
1 jumping jack.
all right, 1 jumping jack.
Everyone.
All right, that was fun. Now we're good. Okay. Law of science time. There's a new sheriff in town, and it's the law. Sorry.
No, contending.
I
No, yeah.
don't know where I was going with that.
Oh.
I'll save you the disgrace. The law of science.
Oh, it's science.
Ah.
I thought it was science.
Yeah, I thought you said science.
No.
Wait, you did? I was thinking we were gonna talk about like chemistry.
Yeah, that's what I was thinking too.
I will do my best to never talk about chemistry in here. Talk plenty about physics, but not chemistry. Physics is awesome. Moving forward here. Here's the deal. Say you don't have a right triangle. You might be like, oh, well, can't do it. You can. And depending on the information we have, you can either use something called the law of sines, or preview Monday, the law of cosines.
It's like the opposite of science.
It's a little different. So here's the thing. Check it out. Say I were to draw this in, and I'm going to call this H. What's the sine of B? And you guys can just watch this part, because this is sort of a derivation of where the law of sines comes from. What's the sine of B? Using my right triangle on the left. H over C, right? All right, how about, let's use the sine of C. H over B. Now, both of those share the letter H in it, don't they?
Yes.
I'm going to solve for H then. I'm going to say that H up here is just C sine B. Down here, H equals B sine C. Well, they're both equal to H, right?
Yeah.
So I can set them equal to each other. And let's divide both sides by the sine of C. And that's gone. Divide both sides by the sine of b. And that's gone. And we can show in another relationship. This is the law of sines. Hang in there. And here's things that you do want to start writing down. Now, I'm guessing you might be a little bit thrown by the fact that there's two sets of equal signs. And that's simply just to show you how the three sets of angles and sides relate to each other in any triangle using sine. Okay? Again, just like everything else, once we start solving problems with it, I hope to put you at ease if you're a little dismayed right now. Now, there's also the same exact thing, which is the reciprocal of that. And let's actually talk about when these get used. What are the lowercase letters again? Sides or angles?
Sides.
They're sides, right? So I like using this top one when I'm solving for a side. The book is not going to write it this way, but we're smarter than the book always. So we can just throw the book under the bus whenever we need to. And we're going to use this second one when we solve for angles. Again, I'll show you how, and I hope you're like, oh, this isn't so bad. Just in case you were wondering, the law of cosines is even crazier looking, and it's even easier. So sometimes math looks a lot harder than it is. Let's do it though. Let's see how this works. So I'm trying to find the side YZ. It's not a right triangle, right? So I can't use SOHCAHTOA. It's not a 30, 60, 90, or 40 by anything like that.
No.
It's not a Pythagorean theorem problem. However, we can rock the law of sines here and figure out what YZ is. Now, what's the angle across from YZ? It's 51 in what letter? It's X, right? So I'm gonna, even though they want YZ, I'm just gonna label it X because it just makes it easier to have just a little X in our formula. So we're going to say X over sine of the angle across from X, which is 51. And now I need another set of side and angle across from each other. Well, we know that there's a side of 7. And do we know the angle across from 7? 77. So this is going to be 7 over sine of 77. Yeah, setting that up may have felt a little weird because it's the first time you've used it. But you'll get the hang of it in no time, I promise. Why are there two X's where?
Because one X is the side and the other X is the equal.
That's why it's
Lowercase.
written a little bit smaller. Yeah. This is side X and that's angle.
Higher space.
Good question. So, hey, go back to The fact that we're doing algebra now. X is being divided by what? Sine of 51. So we're just going to multiply by sine of 51. Those cancel. And I'm going to rewrite it because this is exactly what we can put into the calculator. 7 sine 51 divided by the sine of 77. I'll give you a second to write that down. And like a lot of things in math, we can have a good idea of what our answer should be before you type in anything. Is it going to be bigger than 7 or smaller than 7? Smaller because it's across from a smaller angle, right? Yeah. So here, I'm going to type this in. 7 sine 51 over sine 77. 7 sine 51 over sine of 77.
Yes.
And I got 5.58, or 5.6 if you want to do it. Maybe you just typed in one of the angles slightly
Did
incorrect.
you click like
Yeah, did you even
the
like,
wrong button?
yeah, facts. That's the wrong button.
No, did you click?
Here, let me
the
check.
sign one or the other one?
Or it could just be Hank is just reading it wrong. Hank, special. Oh, class is almost over. No, I'm so hungry. Yeah, 4 minutes out of it. My calculator doesn't look that. Oh, I see it. Clock. Huh?
So
Whatever you see.
see if you can get side XC. Well, Mr. Sunderland, we don't know angle Y. What is it?
52.
Nice. Doing some math, that adds up to 128, so 52? Okay. So, what are we trying to get this one? I'm going to call it a lowercase y. And I'm going to say y over sine of 52 equals, we've got options now, but I think it's always a good move to use what was already in the problem and do 7 over sine of 77. Same deal. In one step, I get y by itself by just multiplying both sides by sine of 52. And we should expect something a tad bit bigger than 5.6. Was it 5.7?
5.7. Really track this, so 5.66 to be more exact. Round it up.
5.66 or 5.7?
Yeah.
Yeah, good. A few things. We've got a little bit of time. Let's,
Wait, can you go back for a second? Thank you. One? Was that
No.
one? Okay.
I don't know what Hank. Oh, I put a 5. Dude, Hank, you can.
hey,
Like it's, I can't read my handwriting.
check it out.
Check it.
We're going to get angle N. Guess what we're going to use? The law of sines, but we're going to have to eventually do an inverse sine. So check it out. I'm going to start with sine of N over What's the length of the side across from N? 2 equals, tell me what your instincts say the right side should be.
M 70.
Sine of 70 over 4. 2 steps here. First, I need to get this 2 out of here by just multiplying by 2.
Oh,
And then how do I go from sine of n to just n?
divide by sign.
It's not what we did before.
The reciprocal was to the.
Oh, yeah.
Inverse sine, right? There you go. So n equals the inverse sine of this monster.
Oh, I got this. No,
Here's where
you're gonna type
you gotta
something
be
wrong.
really careful with your parentheses. Make sure you close the parentheses after that 70.
Wait, where do you get 2 times sine?
What's that?
How do you get 2 sines?
Okay, did anyone else?
I've multiplied both sides by 2 to get this 2.
Why are you going so fast?
Oh, I got.
No, you're just slow.
28 degrees.
I got 28.
That might work.
We're in
So here.
Let me try. Hank probably is gonna get like 29.3 or something.
Wait, so it's.
Sine inverse of 2 sine 70, close parentheses, over 4,
You go, Hank. Oh.
28 degrees. Now, here's the deal. Listen. We can have more time to like polish up inverse sine and stuff Monday. You've been assigned the homework from this section, which is like 8.3.
Yeah, it is.
It's not due until Wednesday. But if you feel like you know enough to go ahead and do the homework, great. Hold on. Here's the other thing. In the weekly outline that I showed you guys yesterday and that you have access to in classroom, there's now a video you can watch explaining everything we just did on the log signs, like really slowly, okay? It's me talking and slowly, and hopefully it's informative. Like, I really want to make sure you get it, Luca.
I got, yeah. I keep
Nice.
on my calculator skills. Hank just had in my hand.
Nice work.
I keep writing instead of sign.
You just covered a lot. You're very welcome, as always.
Oh, man. Matthew's so bad. I know, it's so funny. Next time. Bro, he just- he's funny, guys.